Prism and dispersion of light. You must have seen a prism in your science lab. What is a prism? How does it look like? A prism is a transparent optical medium bounded by 3 rectangular lateral surfaces and 2 triangular surfaces which are parallel to each other. Of the 3 rectangular faces, 2 are well polished and are called the refracting faces. The 3rd rectangular face is grounded and is called the base of the prism. Let us consider the prism with triangular surfaces ABC and PQR and rectangular surfaces ABQP and APRC. BQRC forms the base of the prism. Here, angle A between the 2 rectangular refracting surfaces ABQP and APRC is called the angle of the prism. The angle of deviation is the angle made between the incident ray of light entering the first phase of the prism and the refracted ray which emerges from the second phase of the prism. When a white light is passed through one side of a prism, a band of 7 colors appears on the other side. Do you know how the ray of light is converted into different colors? This happens because of the phenomenon of refraction and dispersion. We already know that the angle of refraction depends on the color of light. White light is made up of a spectrum of colors, so each color will be bent by a different angle. Dispersion is the phenomenon of splitting of a beam of white light into its constituent colors. Consider this experimental setup of a torch, a prism and a screen. Take the prism and place a screen behind it. Now allow a narrow beam of white light to pass through the prism. This white light splits and we can see a band of 7 colors on the screen. Now place another prism between the first prism and the screen. The second prism should be placed in opposite direction to the first prism. When the dispersed light of the first prism flows through the second prism, it gives out a white light on the screen. From this experiment, you have understood that the prism can be used to split the light and the same can be used to combine the split lights. Have you ever wondered how a rainbow is formed? Why stars twinkle? Why the color of the sky is blue? Why do objects waver when seen through hot air? Or why the sun changes its color when setting? Let us now learn about all these phenomena in detail. We have seen rainbows when rain and bright sun happens together. Formation of rainbow is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. Random wavering or flickering of the objects seen through a turbulent stream of hot air rising above a fire or a radiator is due to atmospheric refraction. In this case, the air just above the fire becomes hotter than the air further up. The hotter air has a refractive index slightly less than that of the cooler air. Due to variation in the refractive index of the medium, the apparent position of the objects seen through the hot air fluctuates. We have seen the stars twinkling in the night. When the starlight enters the Earth's atmosphere, it undergoes refraction continuously before it reaches the Earth. As a result, when we look at the stars, they appear to be twinkling. The blue color of the sky, the reddening of the sun at sunrise or sunset are all due to atmospheric scattering. The blue color of sky is because of the molecules of air and other fine particles in the atmosphere have size smaller than the wavelength of visible light. Hence, blue light, shorter wavelength, is more scattered compared to red light. At sunrise and sunset, sunlight enters our atmosphere at a shallow angle and travels a long distance before reaching our eyes. During this long passage, most of the blue light is deflected away and virtually all that we see coming to us from the sun is its red and orange wavelengths. Due to the scattering of light, the wood in the background is seen like behind a bluish veil. Have you seen the dust particles rising in the air when sunlight comes in through a window or door? Do you know what causes this? This is nothing but the Tyndall effect. It is caused by reflection of light by very small particles in suspension in a transparent medium. The phenomenon of scattering of light by the colloidal particles is known as Tyndall effect. The Earth's atmosphere is a heterogeneous mixture of minute particles such as smoke, water droplets, dust, etc. When a beam of light strikes such tiny particles, the path of the light becomes visible. The light reaches the observer after being reflected diffusely by these particles. The color of the scattered light depends on the size of the scattering particles. Very tiny particles scatter blue light, while particles of large size scatter light of longer wavelengths. In this lesson, we have seen how a prism works. We have also learned the phenomena of dispersion, atmospheric reaction, and scattering of light. Now we have a question for you to think about. Haven't you noticed the color of the sea? The sea appears blue on clear days. We know that water is colorless,